Hey, I'm going to be showing you guys how to install PyAquaticus for the 2025 Maritime Capture the Flag competition. Um, so first thing you're going to want to do, head over to our competition webpage, um, read a little bit about it. You can see all the steps for installing training agents, competition history, um, and the past competition and kind of the algorithms that were used from these tabs. But we're going to start off. First, we're going to go to get the code from the GitHub repo. Go over here, you're going to copy it, then you're open up a command prompt, then you're going to navigate to your folder, and you're going to do git clone, and you're going to paste in that copied link. That's going to download, then you'll be left with a folder that's like this, PyAquaticus. If we open up this here, we've got PyAquaticus here. We can go inside and kind of have a setup conda environment.sh, and then we also have a PyProject toml. So we have kind of two ways to install. And here we have kind of the description on how to install on all the different devices that you might have. Here we're doing it on Windows, but the steps are pretty much the same for everything. We made an update so that is the case. If you have Miniconda, that's the easiest way to do it. If you are on Miniconda, you're going to just call that setup conda environment.sh. Light if you just want the environment, full if you want Ray and Torch and all those packages for actually training agents using our sample scripts. Uh, we're recommending you're going to do that if you're going to use deep reinforcement learning and use Ray and all that stuff that's already there for you. But if not, you can just install the light version of it. But if for whatever reason you can't install Miniconda or .sh, like running shell scripts isn't available to you, you can just pip install everything. So I'm going to show you how to do that here. So first thing you're going to do, navigate into the folder. Navigate into the folder. Now we're in the folder to show you. We're going to do pip install -e. We're going to do dot for the directory that we're in. And for the, if you just want the light environment, you're just going to run this. It'll just install the environment. If you want the full environment, we're going to do torch and we're going to do ray. That's going to install ray and torch. So click enter. It's going to install everything for us. Again, you can create a, instead of installing it directly to your Python environment, you can create a Python virtual environment with Python 3 or just python-env and then the name that you want the environment, and you activate it by um, typing source and then putting in that path to that environment. Um, or you could use something like Conda or Miniconda to handle that for you if you want to, or you can just install it directly. It's up to you. But now that we have it installed, we're going to RL test folder, and inside that we have train 3v3 and deploy 3v3, and these are what we're going to use for our 3v3 competition. So I'm going to just delete this folder to show you that we're not hiding anything. So I'm going to start off by running that train 3v3. And here it's going to do a loop. It's going to save out our train policy. And to give you a little bit about behind the scenes of what's going on here, is this is a file that you'll change if you're going to use deep reinforcement learning or any sort of in Ray within PyAquaticus. If not, you can use whatever packages you prefer. You just have to make sure that it formats well within the submission system, which will be kind of a separate video. But we have kind of a few key aspects. So first, this class is a random policy. It's an example of a policy that you want to load in that's like fixed. So if you want it to do the do nothing action, you could make it pass in -1. Here it's just taking a random sample over the action space for each agent. And further down the line, we have this reward configuration. And what this is it is specifying for each agent, specifically the only ones we really care about are the agents that are actually going to be learning, and putting a map to a reward function that it'll be using. And that can be found in PyQuaticus, utils, rewards, and that'll give you rewards.py. And in that rewards.py folder, we have a list of all the attributes that you can access and what's inside them, kind of all the information you could probably want. We have an example, let's just baseline, just like you can pass it through. It'll always return 0, but like how you should format your reward functions. And then we have a sparse example where it just rewards for captures and grabs. And the main thing to note here is we're getting the exact state a capture or grab happens by looking at the state where an agent has grabbed the flag, and in the previous state it didn't have a flag. And so that's the step where a flag was captured or a flag was grabbed, and then we're rewarding the whole team for a team grab or team capture. And then we're always penalizing the agent for going out of bounds. So for key events, if you only want to reward it for that state, you have to keep in mind that you have this previous state and the current step state to use to compare to get the actual value. A couple other parameters in there, but feel free to check that out and update and change this to however you want to train up your agents, if you want to train up your agents. So now that we've imported that, we have configuration that we can change. We can adjust the speed up factor. We can make the game shorter so we don't have to play a full 10-minute game when we're training agents. We can turn off tagging on out of bounds during the actual competition. This will be set to true, but maybe can help make your training time less. Max score, just a few attributes that you can change. Other things that you might want to look at is going into the configuration file, which is in PyQuaticus in that second folder. I'll just show you. In PyQuaticus again, we have this config.py. Right now it's enabled for all the competition settings, but you might want to change some of the observation settings. Feel free to change any of these observation settings. Just make sure that you're updating the submission setup with these observations so that when you submit your agent to the round robin, we can give your agent the observation space that it was trained on. Otherwise, it'll cause an error and it won't compile successfully. But we have short observation length, long observation history length, and then the same for the global state. So feel free to change these and get values that you think lead to the best performing agents, whether that's with training, without a heuristic. It's kind of up to how you want to approach the problem. Then we have the policy mapping function. So what this does is it takes in an agent ID and it's just going to map it to the policy that it's going to use to compute the action. Or if it's a learning policy, use to compute an action and then later update that policy. And so that's what is being done here. And in our case, we're only training 3 agents. We're training agent 0 policy, agent 1 policy, agent 2 policy. All the other agents are set to random. If you want to train 6, you can. You just have to change the policy mapping function and the policy dictionary. Again, after you've trained a set of agents, you can add in more policies and remove policies. I would suggest that you go look at the Ray documentation for doing so. But in our case, we're using PPO, so we're loading in PPO. We're setting that we want 3 PPO algorithms. So we're telling them agent 0 policy, agent 1, agent 2 are all training. And then we're going to loop through and then save it out into the Ray test folder. And this is where we're going to grab our saved out policies, which will then be used to load in later. So now that we've got a checkpoint, I'm going to end it early. So we can open, let's go back to our folder, and we see in array test we have iteration 0, we have policy saved out, we have agent 0, agent 1, agent 2, and these are going to be useful when we try to load to see how our policies are actually performing. And we have something pre-written for you to do that. Let's deploy 3v3. And so in this, how it works is we're going to just take in 3 policies as arguments, and then we're just going to load them in using arrays load from checkpoint. And then we're going to compute an action for each policy at every step, and then all the other agents are going to do the do nothing action. Again, modify this. You can train in self-play. You can also test everything in self-play. You just have to modify this to have these agents actually compute actions and load in those paths. But how do you run this? Do an example. We have rate tests, we have iter 0, we have policies, and then we have agent 0 policy. And then we can just click enter. And this should load up the capture flag game, and we should see that our 3 agents on the blue side have loaded in the policy from array successfully and are computing actions and playing the game, although it's trained for 1 iteration, so nothing too exciting is happening. But that's how you can get started training your agents. Again, take a look at the competition website. We have a kind of a brief history of the competition. We also have a link to a paper of the last year's competition results and some of the algorithms used by each team submissions. So take a look at that and build your competition submission. Looking forward to seeing it.